Hi, I'm Andrew Glaser from the Glaser Tutoring Company, and today I would like to teach you how to use the Rational Zero Theorem to find the real rational zeros of the following polynomial function of x raised to the fourth plus 2x cubed minus 4x squared minus 10x minus 5. So what in the world is the Rational Zero Theorem? Well, it basically says that if you find the factors of your constant term, remember the constant term doesn't have a variable associated, and you call those factors p. And then you take the factors of your leading coefficient, which is the coefficient of the highest power of x in this problem. There is nothing there, so it's assumed to be a 1. And you call those factors q. Then if you take the factors p and divide them by the factors of q, you're going to get a list of possible real rational zeros. Some of them might work for the function. None of them might work. All right? It's like a big guessing game to see, without a calculator, what's going to work. So let's list them out. So what are the factors of 5? You don't have to think about it as negative 5 because every time, it doesn't really matter if you did. But what you're thinking about is two numbers that multiply to give you 5. So it's 1 and 5, whole numbers that is. And each time you write a factor, you're going to write plus and minus because technically all the factors are going to be plus or minus. Then you're going to find the factors of your leading coefficient, which is just in this case a 1, right? And positive and negative. And then what you're going to do is this now will give you a list of the possible values. You're going to take each the numerator value and divide it by each denominator value. So in this case, it's positive negative 1 divided by positive negative 1. That'll give you a value of positive negative 1. Then the second value is positive negative 5, and you divide that by that denominator, positive negative 5. So the other possible set is going to be plus or minus 5. So in this problem, this one's actually not that bad. Not like the other ones that we do where we have like 27 values. Well, you can't really have 27 values, but... well, you probably could. Yeah, you definitely could. In this problem here, we only have a possible list of 4. All right, now, for this function, it's a quartic, right? So it can have a maximum of 4 real zeros. Now, those zeros might not be rational. They might be rational. I don't know. All right? Or they might all be imaginary, in which case none of these would work. But the idea here is this. What you're going to do now after you have your list, remember there's really 4 possibilities here. Positive 1, negative 1, positive 5, negative 5. The idea now is that you're going to take one of those values. Let's take positive 1. And you're going to plug that in everywhere you see x. So there's going to be plus then 1 cubed. Well, plus 2 times 1 cubed, right? Minus then 4 times 1 squared. Minus 10 times 1, minus 5. And what I'm going to check to see if this equals 0. Okay, that's what I'm going to check. So this is a 1. This would be 2. This would be minus 4, minus 10, minus 5. This isn't looking too promising. Does this equal 0? I don't think so. So what that means is that one of the possibilities you listed, positive 1, is not a 0 of the function. You got to remember what it means to be a 0. The 0 values of a function are the values of x in the function that result in an overall value of the entire function being 0. Okay? So positive 1 doesn't work. Now what you can do is you can test negative 1, and then you can test positive 5 and negative 5. And you can do that. That's fine. You could do it out long ways. You could use your calculator, whatever. But I think a much more efficient way, now let's gain a little bit of insight graphically, because pictures are worth 1,000 words. So now what I want to do is graph this thing, all right? I want to see what it looks like visually. Let's see if that'll help us out. So it's 4x, x raised to the fourth plus 2. Where's my 2? There we go. Where am I? I don't even know. What's going on? Who am I? Minus then 4x squared. Man, it's a strange place in my brain. Minus 4x squared, then minus 10x. All right, then minus 5. Now what you're going to do after you plug that into your y equals, you're going to hit graph. And this is now the function. Okay? So let's pull this on down. Now, what this looks like to me, now remember, each one of these tick marks represents a value of 1. So I think, you might have to zoom in here a little bit, but I think it can clearly be seen that this 0 value, this is definitely a real 0. It crosses that x-axis, but it's not, it probably might not be rational. I mean, we'll see. We'll see what the number is going to work out to be. But this is definitely not negative 2. All right, and I didn't even have a list. Remember, my list here, which is being hidden Yeah, let's move that over. My list here was only this little rational zero thingamajig. This theorem only gave me 4 possibilities, and it looks like maybe one of them might work, right? The -1, this looks very close to -1. But these other zeros, they don't work. Doesn't work. Okay? So now what we're going to do is I'm going to check the -1. Okay, I'm going to check that. And what should happen is that this should work out. So if I typed in -1 raised to the 4th plus then 2 times -1 cubed minus then 4 times -1 squared minus 10 times -1 minus 5, does this equal 0? All right. So anytime you have a power that in even power, the whole thing's going to be positive. So that's a positive 1. My brain was thinking even, but no, it's going to be positive. Anytime you have an odd power, you keep the sign. So it's a -1 times a 2 is going to be a -2. So let's turn this into a subtraction then, right? There's going to be -2. Then there's going to be a positive 1. Positive 1 times then the -4 is going to maintain the -4. Okay. Then this works out to be a positive 10. All right, cool. And then this still is a -5. And the question is, does this then work out to be 0? Well, let's see. -2 and -4 is a -6. Then -6 and the -5 is going to be a -11. That's all the negatives. And then you have all the positives equals positive 11. Oh, look, goody gumdrops. It does equal 0. All right, and that's kind of the benefit of our technique. So now the thing is, how in the world do we find these other zeros now? Right? Well, if you notice, you see how this graph just grazes that point. It actually doesn't intersect, right? I'm going to, well, we'd really have to zoom in, okay, to kind of see that it doesn't cross that x-axis. You know what? Why don't we do that? Let me show you how to use the window. So I know this is about -1, so let's go x min is -2, and let's go to x max of 0. So -1 is going to fall right in between, all right? And let's go to y min of like -0.1, and let's go to y max of 0.1. We're really zooming in. And let's graph. You see that? I'm really zoomed in now. Okay, really, really zoomed in. It appears to me that it's probably not going to cross that x-axis, okay? Now what that means then is that the value here at -1 represents a multiplicity of 2, right? If that sounds unfamiliar, we got a whole lot of videos out there on multiplicities. So this 0 value at -1, which by the way, our theorem, Rational Zero Theorem, predicted, the factor associated with this 0 is going to be x plus 1, but it's squared, okay? Now, what we can do from here is I look at now the overall, look at what I got. I got an x to the 4th, all right? And I know I have 2 factors here because it's squared, I have x plus 1 and x plus 1. Now what I can do is I can divide into this function, I can divide x plus 1 squared, okay? I can divide x plus 1 into this function twice and use synthetic division. It really doesn't make a difference. I think I'm going to use long division on this problem though. All right, and I realize that basically after I, FOIL this on out, right, I write now x plus 1 twice, and now what I'm going to look to do is kind of do the first, that would be x squared. You know this, right? X times the positive 1 is going to be a positive x, then positive 1 times x is going to be a positive x, and then positive 1 times positive 1 is going to be a positive 1. Combine those like terms, so it's going to work out to be 2x, right? So it's x squared plus 2x plus 1. All right, so now what I'm going to do is just erase this and write that in. So that's going to be x squared plus 2x plus 1. I realize that if I start with a quartic and I divide it then by a quadratic, I know I'm going to result in a quadratic at the end. Okay, now what I should anticipate is I should anticipate this going into this function evenly. All right, because I know, and I proved with the graph and also with this remained rational zero theorem, whatever the heck it's called, I also proved that basically these are 2 factors, right? X plus 1 is kind of a factor twice, so to speak. So let's do out the long division and let's see if that's going to work. Bam. So now what I want to do when I do a long division is I want to figure out how many times the highest power of x will fit into then the highest power of x here, right? This is known as your dividend. This is your divisor, right? This was in the denominator there. This was in the numerator up there. All right, so figure out how many times the highest power of x in the divisor fits into the highest power of x in the dividend. In other words, just take the x to the fourth value of your dividend and divide it then by the x squared term of your divisor, and that works out to be x squared, right? So this is the first value of your quotient up here. Put it on the top. I don't care where you put it, just put it somewhere. Then what you're going to do is you're going to take this x squared value and you're going to multiply it into each term of your divisor here, okay? Now, before you do that, I want you to set this up. Just write a little minus sign and write a big parenthesis, okay? Now do the distribution. So x squared times x squared should be x to the fourth, and if you did this properly, it should match that value. Then you're going to do x squared times 2x, which is going to be a positive 2x cubed. Now, they might match, they might not. I mean, it matches in this problem, but don't think that they have to. Then you're going to take x squared multiply it by a positive 1, so obviously that's just a positive x squared, okay? And you can plug in zeros here if you want. There's nothing else there. Now what you're going to do is you're going to distribute the negative sign to each term on in there. So basically you're going to take all of the positives and you're going to convert them to be negative, okay? Now, that's not a rule for life. Don't do that. You want to do the opposite, right? Turn all the negatives into positives. But here for math, that's what's necessary at the moment. Now, simply perform the operations. So as you can see, these cancel, and these will fully cancel, and this is going to now add up to be positive, positive what? That's really taking the negatives and turning it into positive, huh? That is going to be a negative 5x squared, all right? And then this, you basically just drop these all down. Negative 10x minus 5, okay? Now what you're going to do is you're going to then take, so this is like your new dividend. Now what you're going to do is do the same process as we did before. Take the highest power of x in your divisor and divide it into the highest power of x there in your dividend. So what it's going to look like now, it's going to look like negative 5x squared. Take that whole value and divide it then by the x squared here in your divisor. When you do that, the x squareds go bye-bye and it's just negative 5. So this is negative 5. Okay, that's what you plug in at the top. Let's just erase this to clean this up. How's your year going, by the way? High school, college? Hopefully it's going well, right? Probably about halfway through, whatever you're doing. Yeah, hopefully it's going well, all right? And yeah, I don't know, trying to have a conversation with you. Not really sure how that's going, considering I have no idea who you are, or do I have any idea what you're saying? What? Don't curse me out. That's not nice. Just trying to have a conversation with the computer screen, you know? But leave a comment in the description. Just say hi, so I know I'm not completely losing my mind. Anyway, now what we're going to do is we're going to set up the same thing as we did before. A negative sign, open your parentheses, close your parentheses, and then you're going to do a distribution. Take the negative 5 and multiply it into each term there of your divisor. So first, negative 5 times x squared is going to be a negative 5x squared, and if you did this properly, they should match. Then take the negative 5, multiply it by the 2x, that's going to be a negative 10x. Now they might match, they might not. I mean, in this problem they're matching, but don't think that they have to. A negative 5 times then a negative 1 is going to be a negative 5, okay? Now what you're going to do is you're going to distribute the negative sign, and this is what we want to do in life. We're going to take all those positives, we're going to change all the signs now. So since they're all negative, you're going to turn those negatives into positives. And the way we simply do that is by just going like this. Little line like that. And that's it. Now guess what? When you add all this together, what happens? It all goes to 0. Now that should happen for this problem. And that's what I mentioned before, that if I knew, if this is a factor, the x plus 1, and it had a multiplicity of 2, if this is a factor, and I did all the math right, this should divide evenly into that polynomial. And that's what it had, that it has a 0 remainder. That's what it means to divide evenly. Okay? Now, this is the resulting quotient. Okay, 2x minus 5. And that's what it's right, it's quadratic. 2x minus 5. And the benefit now of this is that I have methods now I can use to solve or to find the zeros or the roots of this thing. Right? I have a nice, beautiful formula. The quadratic function. right? X is equal to negative b plus or minus the square root of b squared minus 4ac all over now 2a. All over 2a. So what you need to do now is you need to, and there's other ways to do this, by the way. It's not like you have to do it this particular way. You know, this, you can shortcut that. I like to use this method, even though it might look intimidating, because guess what? It always works. You're always going to be able to use this. All right. You know, you could think about two numbers that multiply to this, you know, there's various methods, but this will always work. It'll never let you down. So in this quadratic then, remember, when you take this numerator and divide it by that denominator, this was the result. Okay. That was the result. So now what you'd have to do is take this quadratic and you have to identify your a, b, and c values. So remember, the a value is the coefficient of the x squared term, which is a 1. The coefficient then b would be the coefficient of your x term, but you don't have an x term, so that's just going to be a big old 0. And then the constant is your c, and that's a negative 5. So what you're going to do is you plug in now a is 1, and b is c is negative 5, and b is 0. Right, so maybe this might not work out to be bad. So this is negative 0 plus or minus the square root then of 0 squared minus 4 times your a value of 1 times your negative 5, all then over 2 times 1. Right, and when we simplify this now a little bit, it looks like it's just going to work out to be plus minus square root of 20, okay, square root of 20, all then over 2. So this is going to work out to be plus minus, right? So I can break this now up into two values. I can also kind of simplify this, right? Radical 20, all this stuff, right? Radical 20, I'll do it up here on the top left. Radical 20 is the same thing as saying radical 4 times 5. All right, then you can basically distribute the radical to each of those terms. Radical 4, the perfect square, that's what I was looking for. Radical 4 is equal to 2 multiplied by radical 5. So you can write it that way, right? And now what's interesting is that when you do this, you're going to get a positive 2 radical 5 over 2, and you're going to get a minus 2 radical 5 over 2. And wait a minute, the 2's are going to cancel. So what's going to happen? You're just left with positive and negative radical 5. And that's what now this is kind of like, you can turn this into like a perfect square type of deal. And that's fine. You could have shortcutted it that way. All right? You could have. I mean, you could have also just set this thing equal to 0 and solve for x. You know, there could be so many ways. X squared minus 5, set it equal to 0, and you're like, oh, just add the 5 on over. Great, bada bing, bada boom, x squared is equal to 5, and then take the square root. When you take the square root of both sides, it becomes x plus or minus radical 5, and that's what we got. All right, there's so many ways to do this. I like this method, though, the best, because you can use that method anytime. Right, so what I should anticipate now is that these are going to be, these are the other now, factors. All right, the other factors now are going to be, so we said before, let me just erase some of this craziness. So we said before that we had a value x being equal a 0 at x equals negative 1. We also now found that x will also be equal to negative radical 5, and x will also be equal to positive radical 5. All right, and let's see if that's true. Let's go to Zoom. Let's go back to standard, okay? Let's hit 6, hit enter. All right, cool. So now what I'm expecting, what I'm anticipating now, is that this value over here, all right, this value right here is the negative radical 5. And this value over here is the positive radical 5. So how do we kind of show that, right? How do we find that? Well, we can do a couple of things. I mean, you can take now negative radical 5 and you can plug it in for every x. And if you were to do that, the whole thing would equal 0. Okay? That's cool. And you would do the same thing for positive radical 5. That works. So let's see if we can zoom in. So we hit zoom, and let's go number 2, and we're going to zoom in. All right, cool. So now what I'm going to do is I'm actually going to use this calc function. All right, so go to second calc, or second trace basically, and scroll down to 0 and hit enter, meaning we're going to find the 0 of the function. All right, so now move your cursor to the left, and you're going to see it coming on up here, right? And what I want to do is I want to find the 0 value over here. So I want to bring the cursor all the way on over to the left of that mark. That's fine, somewhere to the left. And then bring it to the right of that intersection. So go here, and then guess. Just give it, you don't have to be exact. Oh, it kind of went right there, but you don't, even if you're off a little bit, you're going to be fine. All right, hit enter. And now here's the value. Now it doesn't give it to you in radical form, but this is negative 2.236068. So what we can do now, let's check it. Let's check what negative radical 5 is, right? Let's go second quit. Let's go negative radical 5. Hit enter. Wow. There it is, right? And even if it's off by a tiny, tiny, tiny little bit, that's just because the calc function makes a series of estimations. So it might be ever so slightly off, ever so slightly. But as long as you're like within the ballpark of 4, 5, 6 decimal places, if it's off towards the you're good. You're good. All right. But as you can see, that's one of the zeros. I know the other one's going to work. We don't really even have to show that, I don't think. But that's it. That's how it worked out. All right. So hopefully this now shows you the way to use the rational zero theorem then in a way that you can find then all the real zeros of the function. And you could also use it to find all the irrational, not irrational, even though this is irrational, all the imaginary. Okay, irrational, imaginary. A whole bunch of tongue twisters. But you can also do that too. All right, and you can use the same method to do the same thing. That's why I love it. All right. So anyway, guys, thanks very much for tuning in. I really do appreciate it. I hope this video helps. And if it does, like, subscribe, maybe even tell some of your classmates. Check out our channel too, because we have thousands of videos, not only in math, but chemistry and physics as well. We go through specific problems. That's the best way to study for your tests. Okay, you have to do practice examples and problems, because guess what you're going to see on your tests? Practice problems, right? Well, not practice, it's a test problem now, but you're going to see problems and questions. All right, so check out our channel, try to do the problems, see if you can solve it. Use the video to check your answer, or if you're stuck, use the video to help you through it. We'd love to help you with more. And if you want to continue your education one-on-one with us, check out our website, glasertutoring.com. We'll see you soon. Bye.